Welcome back, everyone, to the AI for Legal series. Really delighted to be here with you, and most particularly delighted to welcome Stan Chua, the Service Delivery Manager Technology at Lander and Rogers, to chat with us today. Hi, Stan. We've got a wonderful presentation focusing on large language models, and I've had the opportunity to have a look at it, and you're really in for something special here. So hold on to your seats and get ready for this one. So Stan, I'm going to go off screen, but I'll be sitting here in the background for you. And otherwise, again, thank you so much for doing this for us, and really looking forward to this one. Thanks, Stan. Over to you.
Thank you, Terry. So first, I'd like to just say thank you, Terry, and thank you, Christine, and the rest of the team to provide this opportunity and to put in the work to get this series ready. I know that there's a lot happening behind the scenes, and really grateful to have this opportunity. Big thank you to each and every one of you for choosing to share your time with me today as well. I know that time is pretty precious for everyone, and the fact that you're taking the initiative to try and understand something that's outside of the comfort zone, I think that's a really big step, because as we all know, technology is really complicated enough, let alone AI. So just to start things off, my name is Stan Chua. As Terry's mentioned, I'm the Service Delivery Manager here at Lander and Rogers. I'm not really an AI expert. The really smart guys on the other side of the world, they deserve all the credit. I'm just a tech guy that enjoys learning about AI. I enjoy learning about things. I enjoy sharing knowledge, and I also enjoy listening to the sound of my own voice. So you get to share that with me today. Now, the topic of this presentation is about AI, and you notice that the title is probably a little bit different from what you usually see. So the reason for that is that if we think about it, it's not just a science fiction topic. We're actually a few steps away from androids becoming real. So when we talk about androids, we basically refer to robots that look and behave like us. Right now, we're not quite there yet, but they're actually good enough to make us believe that they have a mind on their own. But what actually happens when AI gets to a point where they're better at being human than us, and they have the access of the internet in their back pocket? Do they actually understand the idea of hopes and dreams? If, let's say, hopes and dreams are represented as ones and zeros in their minds, do they understand the concept of what is justice, what is fair? And even if they understand it, why should they? Would they be complying with the ethics, the moral codes? To make it easy to understand, say if humans were reporting to ants, and human knew that they were superior to ants in every single way. So what's stopping humans from just breaking off and running off and doing their own thing? So that's something to think about as we run through the rest of the slides. So what I like to do is just something a little bit different. The way I like to do it is just to take you through my journey of learning about AI. We'll share with you the learnings, and hopefully this will inspire you to stay curious. If you don't have any background in AI or tech, that's not a problem, because the way I've prepared these slides is to make it easy for everyone. I like to first say that for all of us, we're very, very adaptable, because a very good example is if you look at your phone, the smartphone, you don't know everything about it, but that doesn't stop you from using it, to use it in a way that provides you value. And I think this is probably the best approach to have when it comes to AI. What I'm hoping to be able to do is to break down the barriers and to help you understand that AI is not as scary as what everyone thinks. I'll take you through the common terms that's been thrown around these days, and I'll show you a little bit about what's the magic behind the scenes. Then we'll talk about the future and why we need to be paying attention now. So let's start about, when we think about AI, the first thing that comes to mind is chatbots. And let's be honest, chatbots are pretty forgettable. I had zero interest in AI before ChatGPT came onto the screen. Why? That's because most chatbots are slow, clunky, boring, and just not impressive at all. Now, when ChatGPT came onto the scene, I heard about it for a few months, but I didn't really bother to look into it. I thought it would just be another buzzword like many others, but one day I decided to just sign up for an account, and it completely changed my mind. So I was asking it all kinds of questions, and it would reply back to me in a very, very confident manner. I could ask it for recipes, theory, logic, science, history, corporate emails, because I really, really, really dislike writing those because I just don't have the brains for that. So when ChatGPT came out, it was amazing. I could give it just my most honest thoughts. I could tell it, don't say this, don't do this, and it just translated back into perfect corporate speak. Excellent. And This email, I must say that I may or may not have sent it to my boss. So for those listening, what I did say was to just put a screenshot of a prompt that I provided to ChatGPT. In the prompt, it says, encourage my boss to let me present at the AI for Legal series webinar. I'm excited, passionate to have the chance to present. Don't say this out loud, but it gives me a reason to not do work on a Friday afternoon. So ChatGPT came back and said, he gave me a template. It says, dear boss, I'm thrilled and passionate about the opportunity to present at the AI for Legal series webinar. It's a chance for me to showcase our expertise and contribute to the industry. Additionally, it can energize me and provide a productive focus for Friday afternoons. Perfect. Now, one good thing about ChatGPT is also that it's very, very accessible. It was easy to use. You didn't have to provide any instructions. It was free and anyone could sign up. It was an instant hit because there's all these different factors that make it easy for people to use. So this is a subject called UX as well as UI. So UX refers to user experience. UI refers to user interface. So interface means that screen that you look at when you use a certain website or application. Now, what a lot of people quickly found was that it's a general purpose tool that you could use to provide all kinds of different values, copywriting, scripts, emails, short stories, the list goes on. The more I used it, the more I realized that I had something in common with a a screaming young child and the Backstreet Boys. We like to ask why a lot. And I couldn't really figure out why. Like, why was it able to know every single topic that I'm throwing at it with such speed and accuracy? How is it doing it? What's the magic sauce? Do they have hamsters running behind the scenes? So I got really, really curious about it. Now, being a tech guy, Google is my bread and butter. The more I read, the more I didn't understand. So I said, let's start with artificial intelligence. We come across these terms, large language models, transformers, machine learning, generative AI. The more I dug, the more questions came out. And it got to a point where I decided to say, what did I actually get myself into? How do I actually make this simpler for normal people like us that don't have any background in machine learning, in robotics? Because I don't really care about equations, vectors, embeddings, all of that crazy stuff. All I want to know is how does the thing work? So after 30 hours of reading, I still have no idea what I'm reading, but I think I'm getting better at it. Now, I am a fan of keeping things simple to make sure that knowledge is accessible and easy to share to everyone, because it's very, very important for us to be aware of what this thing is rather than to be afraid and just say, I don't know. Now, if something is easy to read, I believe that a lot of hard work has been put into the background. So a good example is your phone. It's easy for you to scroll. You don't really need an instruction manual. And that's because they want you to use it. And I believe that knowledge has the same kind of concept. We want to make it easy and accessible so it's easy for you to share it with other people. And the more awareness we have, the more support we'll get. So what I've done here is I've managed to put together all of my research. I've watched a lot of YouTube videos, read a lot of journals. So this is the result. So what I want you to do is just imagine AI as an egg. And if you look at it from a cross section, there will be different layers. So the most outer layer is what we call the eggshell. And this is what we can call artificial intelligence as the eggshell. This is what makes up the entire thing. Now, the next level, which is probably the equivalent of an egg white, this is where machine learning comes in. This is the foundation of everything that we are talking about in terms of AI. Now, if we go a little bit deeper, there'll be a few more different layers in between. So if you are listening to this, what I want you to think about is you've got the egg white, you've got an egg yolk, and you've got two other yolks inside, which I'll run through in a second. So now we've got machine learning. The next layer inside is what we call neural networks. So the word neural actually means nerves and neurons, yes. So it's basically a term to describe the brain, the human brain. So when we talk about neural networks, just think of it as the brain. And I'll discuss a little bit more later. Now we have another yolk in the middle, which sits within the neural networks. This is what we call deep learning. And finally, we have generative AI, which is probably what everyone knows and is keen to hear about. Now, because there's quite a lot of things, we are actually going to just touch on 3 areas here. So large language models sit right in the middle of generative AI. And today we'll just be focusing mainly on machine learning, large language models, and generative AI. Now, in order to talk about these three areas, I'll need to go through from the top to bottom, just so you get a good idea of what we are discussing here today. So let's start from the top. What is AI? We heard that word being thrown around a lot. No one actually comes out and say it in simple English. Now, to make it very, very simple, AI is basically just a type of computer software that's trained to do things like a human, period. Now, what is the purpose of it? The purpose of AI is basically to free up our time by solving problems for us. And how do they do that? They do that by getting computers to think and behave like us. That's simply the essence of AI. Now, if we start to break it down into different categories, AI actually has three types of it. And I'm going to quickly touch on those because I think it's important to understand what they are. So as previously mentioned, there's three types of AI. The first one is what we call artificial narrow intelligence, or in short, ANI. So ANI, what they do is that they are basically built to focus on a single task, and they have limited capabilities. So in essence, they are smart, but they're only good at doing one or two things. Now, this is actually where we are today. A lot of the AI that we are speaking about, they're still in the category of ANI. Now, the next category is something you might have heard of, which is AGI, and we call it the artificial general intelligence. To put it simply, this is AI that is as capable as humans, as smart as humans, and they understand things that are intangible, such as emotions, beliefs, and desires. Now, you might be wondering, why should I care? Well, the thing is, I want you to think of AGI as a teenager. So for those of you who have children, you would understand this. Teenagers learning about the world, and they go through different phases, and they understand that, hey, I feel like I'm on top of the world. People can't tell me what to do. And I have the capability to flip the world upside down just for fun. Now, what's concerning here is that we've already seen the capabilities of ChatGPT. It's able to understand, predict, and analyze what we give it with super accuracy. AI has also gone through the bar exam, different exams, IQ tests. They've already proven that they're able to produce at that level. So think about it. If you've got a teenager who's smarter than Einstein, who's got the internet in the back pocket, what's going to happen? And plus, there's no consequences for it. You can't really shut it down. If, let's say, we get to the point of AGI and there's no rules, there's no restrictions, there's no guidelines in place. So what we want to do now is to make sure that we're ready for that. It could be 3 years away, it could be 5 years away, we don't really know. But we want to make sure it's ready, because if AGI comes around and we're not ready, there could be a lot of consequences, and it's going to be hard to put the genie back in the bottle. Next, we're going to talk about this thing called artificial superintelligence. So we know that AGI means that the AI is as smart and as capable as us humans. So ASI basically means that this AI is much more capable than us in every single way. It's able to have emotions, it's able to have beliefs, it's able to have desires. Now, that brings up the next question. How will ASI look at us humans? Back to that example I spoke about regarding ants and humans. If you know that you're capable and you have all the control and power over this other organism, what's stopping you from just saying, I'm not going to follow you, I'm going to do whatever I want? So that's a really concerning thought. And this is also why there's a lot of emphasis now to say we need to put some regulations in before anything goes off. All right, so we're going to quickly touch on machine learning. So what is machine learning? When we think about machine learning, we might picture a robot sitting in front of a computer, but that's not probably the closest thing we can describe. So what you see here is a video of a robot that Google Research has developed. So what it's doing here is that there's a human giving voice commands to the robot while the robot is using the video input and text commands to move the colored blocks to put them in order. This is what we call supervised learning. And this is one of the more simpler examples of machine learning, because it's taking the inputs from the human, translating it from speech to text, and at the same time having computer eyes, which is the video input, so that it can align the blocks in order. And the caption in the video is basically a translation, sorry, not translation, just a caption of what the human is telling the robot to do. So it's just asking it to nudge the red circle to the top, the yellow heart up, and so on and so forth, so that eventually the blocks are aligned together in a row. Another example of machine learning, which might be surprising, is the spam filter in Gmail. This is something that not a lot of people might know, but Google actually uses a lot of machine learning, and this is one good example. So if you think about it, machine learning isn't really that scary because it's really part of our lives. We just don't really know about it or hear about it. So how do we break this down? To put it into simple words, machine learning is basically just instructions to tell computers how to learn from training data independently. What the computer does, it picks up different patterns and it learns to predict the future from there. So to use an example, what it means is that if I give a computer 3 blocks, say a triangle, circle, and a square, and I teach it, these are the shapes, the next one that comes through, and I could tell it, hey, what is the shape? It's able to say, yep, based on what you've taught me, this is a square. Now, the goal of it is pretty straightforward. We want it to be able to learn and improve from the data that we give it. And we don't have to go in there and teach it to do. So a practical way is that we can give it a lot of medical images, and it could go through it. It could learn what, say, a tumor looks like, COVID looks like, and it's able to pick up and identify and give you results from there. So for machine learning, there's 3 ways we can usually do it. The first way is what we call the supervised learning. So this is where we give it some objects. So similar to the example I just said, for this one, we give it some fruits. So cherry, watermelon, tomato, cake, cheese, and a hot dog. We teach it what to do. So I can say, here's how you put them according to fruits. Here's how you put the second one according to a food category. Now that I've shown it, I would tell it what results I expect. After I tell it the results, I expect it to do the rest and it's able to pick it up from there. So moving forward, if I give it any kind of fruit or food, it's able to identify this by itself. Second one is what we call unsupervised learning. This is where we give it a whole bunch of random objects, random data. We don't know what it is, and we just tell it to go and figure it out. So this is good because when we have complex data that we have no idea what to do. So for example, medical records or stats from a very, very complicated Excel spreadsheet. This is where we tell it to do, you need to figure out what's the common denominator, what's the pattern between these, and I want you to come back with your results. The last one is what we call reinforcement learning. So instead of telling it what to do, we simply give it a goal. We tell it, this is the goal you need to reach. So in this example, we say, we'll give you some objects. Your goal is to identify what's common between them. You can do it however you want it. If you succeed, I'm going to give you a reward. So in this way, the machine is actually incentivized to look for rewards, to get rewards, and it's going to figure out by itself. So this is really good because it's going to give you unexpected answers. You're going to be able to find flaws in your algorithm or in the program that you're trying to build. And this has helped scientists and engineers a lot because they're learning a lot of things that they don't understand. So like I mentioned, machine learning is actually around us everywhere. One of the examples I just mentioned was Gmail. You've got it in your spam emails. Uber, how it estimates your arrival time for every trip that you get, how it calculates the search pricing. TikTok, this is where it's got some maths behind the scenes to recommend you popular videos that other people are watching. Spotify, this is where they would suggest playlists or music that they think you might like. So then we get to the next point about neural networks. So what are they? To put it in simple terms, it's basically machine learning version 2. So whatever we've talked about just now, we just give it extra brain power now. Now, as we know, our brains are pretty complicated. We've got a lot of these, we've got billions of neurons that helps us to think and learn. So neurons are little cells that look like this. How it works is that they pass electrical signals between each other and to other parts of your brain and to the rest of your body. So when the engineers and scientists decided to create something, they decided to model this after our brain. But unfortunately, it doesn't really look as exciting as that. So if we look at it from the AI perspective, these neurons look a little bit more like this. Not very sexy, but you get the idea. And with these neurons, they might represent them as circles on diagrams, which I will show you in a second. And To keep it simple, the goal here is just to copy the way we process information and make decisions. Because if we go back to right to the top, we want these computers to be able to make decisions and think just like us. So if you're still with me at this point, I'm just going to quickly touch on how it works. Now, if you picture 3 boxes from left to right, yeah, this is the way we actually process information. So if we start from the left, you have a box that's in charge of managing questions. There'll be a box in the middle, which is pretty much the brain, which handles the thinking, the processing. And the final box is where you get the answers. So we use a very, very simple example to explain what this looks like. Say if I get a question called the sky is, and I need to fill in the blank. The brain would then think about it and it would spit out the answer blue. So how does it work? Now, what I'm going to share here is a little bit about how AI breaks it down its way. So instead of looking at the entire sentence in one chunk, it breaks it down into 3 different bits. So if there's 3 words in the sentence, it'll break it down into 3. If there's 5, it'll break it down into 5, and so on and so forth. Next, it passes each word into its brains. And from there, it's going to look at it to understand what's the relationship, how it works, what are the possibilities, based on past experience, based on all the English words it's read, what's the possible answer out of this? So it could be looking at saying, cool, if I look at 3 words, the sky is, there's a few different options. Sky is the limit, sky is falling, sky is blue. Cool. Then it takes a little bit further to look at the relationship between the words. How does the word "the" fit into a sentence? What does "is" referring to? What about sky? Does it fit together in this order? And is there a logical meaning behind this? So at the end of it, after the brain does all of the processing, it looks at it and it says the sky is blue. Now that we've had a good understanding of how it looks like, let's take a look at the inside. So if we take off the cover, this is how it looks. It looks a little bit scary, but the easiest way I can explain this is that for each of these little circles there, I want you to imagine them as 3 junior lawyers. So on the left in the input layer, which is the question layer, imagine the 3 circles as 3 junior lawyers that you have. Their job is to basically ask questions. Now the middle layer, which is the brain or the hidden layer, would be 4 very experienced lawyers, let's say in-house legal counsels. They'll be there to debate, to analyze, to ask the questions. And once they're happy with it, they pass the answers to the very, very experienced lawyers, which could be, say, the partners. The partners would then decide at the end to see which of the submissions sound the most reasonable. So the lines that go in between, think of it as just in the example of lawyers and communication, we could just say that they could be emails going back and forth, Teams, Slack messages going back and forth. But to make it simple, we just call them connections here so you can understand the relationship between them. So here's the thing. What if we decide to add a few more layers in between? So when we add layers, we increase the number of people in that team. And how would they look like? So everything stays the same. The only difference is that the hidden layer or the brains in the middle, you get a lot more nodes sitting there. And what does this mean? So if we go back to the previous example, now you have 3 junior lawyers asking a team of 12 in-house counsels to run through, to debate, to ask questions. That means you can get things done quicker. You can ask more questions. You can get more quality results. And then you can then pass it on to the last 3 partners to decide which outputs are better. So in short, more layers equals more brain power. That's all you need to know. And this is what we call deep learning. So the word deep refers to the layers in between. Anything that's more than 3 layers. So 3 layers in this case refers to the input, the output, and the hidden layer. So anything more than 3, which is usually in the hidden layer, this is where we call it deep learning. So I've done quite a bit of explanation on that piece. But if you got lost in the middle, all you need to remember is that this is the neural network version 2 with extra brain power. That's it. So obviously there's a lot of advantages here. It's able to do things quicker, better, faster, more accurate. And there's a lot of possibilities that we can unlock because with deep learning, now we get more brain power, now we get more options, and we can feed it more data, which means that we can get more results, more possibilities, and more suggestions on what we can do. So this is the foundation of what generative AI is built on. Without deep learning, there's a lot of things we can't really do. And I'll touch a little bit more on the next slide. So the goal is basically to teach computers how to process data like the human brain. Now, as we know, a lot of things that we take for granted, we think that it's basic. But for example, for me, holding up this glass of water, that takes a lot of brain power. It's just that it's so natural and normal to us. We don't even think about it. And another example is me sitting here looking at the screen, these words coming out of my mouth. That's actually a very, very complicated task for computers. But for us, we take it for normal. And I think at this point, it's pretty important to say that we are actually very, very amazing as a creature because we are doing so many complicated things. We are processing so much complicated data. And I think we deserve a bit of appreciation. So again, deep learning is quite similar to machine learning. It's already next to us. There are a lot of different examples that I can pick from, but I think these examples would be a bit more relevant. So for those who use the iPhone, when you unlock your face with Face ID, that's part of deep learning. When Facebook is giving you names to suggest to tag, that's also part of deep learning because it's able to understand, analyze, and pick up the faces. You've got the self-driving technology in cars because it's doing a lot of calculations on the fly. It's looking at cars in front of you, real-time traffic, obstacles right in front of the cars, behind the cars, on the side, speed limit. There's a lot of things going on there. And finally, we've got Netflix recommending TV series. This is also part of deep learning because it's understanding preferences, understanding the demographic, the age group, what do people in the 20s like, what do people in the 30s like, what would they like to see? All right, here's the fun stuff. So what is generative AI? I believe a lot of us have heard about it, but it's very, very simple. To describe it, it is a category of AI that is built on the deep learning algorithms to create new unique content. Now, text is probably the most familiar one that we know, and this is what we're going to touch on today. A good example is ChatGPT. For image, we've got Midjourney, we've got DALL-E. Voice, we've got Google Soundstorm. Music, we've got Music Gen, and the list goes on. So to keep it simple and short, I decided to just use these 4 examples. The goal here is to just create models that can create and generate unique content via prompts. So you can see here that it's not just limited to text. There's a lot of different use cases, and this is probably just the tip of the iceberg. Now, how do we actually use it? Because a lot of us here are from the legal industry, I thought what I'll do is just to list out some things that are more relevant to us. So for us, some of the things that we can consider, there'll be an option to create a self-service Q&A application, which will answer, say, in-house legal questions or external-facing client questions, questionnaires, and so on and so forth. Drafting legal documents, I'm pretty sure everyone is pretty familiar with this at this point. So we want to create tools that could help us draft up documents, contracts, memos, policies, and advice, so on and so forth. Classifications of contracts and documents. This is another big one because when you have a large stack of documents, it's very, very time consuming. You need someone to help to process quickly. And with a generative AI, this is where we could utilize it. Same thing, extraction of key data from large portfolios. If you've got a 5,000 page document, you probably won't have time to go through it to pick out what's relevant or not. If you have AI to do this for you in, say, 2 minutes, you could easily use that time for something else. Now, finally, we've got the section about summarizing and analyzing legislative changes. Say, if there's a new piece of legislation coming out and you don't have time to read it, you want AI to be able to quickly tell you what are the relevant points so you can make a decision. Same thing for legal research and for reports. The whole idea about AI is to save you time. You want to use that time to do better things rather than to run around in circles, trying to chase up people, chase up emails, trying to do Control F. So this is the whole idea about what kind of possibilities are there. Cool. Now we've got large language models. What is it? Large language models essentially is just a computer software that understands and is very good at the human language. They call this the natural language processing. But to keep it simple, it's a software that's really good with the way we talk, the way we write, and the way we interact. In 3 words, autocomplete on overdrive. If anyone asks you, that's all you need to tell them. It's super good at autocompleting, and it's super good at reading context. Now, the large in large language models refers to three things: the size of the data that is being trained on, which is a good combination of books, articles, journals, as well as a lot of things of the internet. The size and the complexity of the neural network that it was built on, and the number of settings and rules that it needs to understand and retain about how human language is done. So this actually refers to all these parameters that you keep hearing about, because without these settings and rules, it's not able to understand, say, I am so-and-so, or she is so-and-so and so, or the size and complexity of, so all these are sentence structures that it needs to remember. Obviously, what it means is that the more parameters you have, the smarter it is. Last thing to quickly touch on is the token. So this word comes up quite a bit. To make it simple, I want you to think of it as ChatGPT being a vending machine. There's a condition to say that you can ask it anything you want and it will give you the answer, but you need to spend $10 on it. Every time you approach it, you need to spend $10 and it only takes $1 coins. Now, the tricky bit is that out of the $10 coins, out of the 10 coins, you need to choose either between a short question. So say if I spend $2, 2 coins on a question, I have 8 remaining for a good answer. So if I ask a short question, that leaves me a lot of gap, and I can probably get a quality, good, detailed answer from there. If I ask it a long question, say 6 coins or $6, and I leave $4 at the end for my answer, what that means is that I can give it a lot of details about the questions that I want to ask, but the answer that I get might be cut off. So to put it into perspective, what we currently have and understand is that for, say, example, ChatGPT, you've got the limit for 8K or 8,000. And I believe the current threshold is 32,000 tokens. Now, 32,000 may sound like a lot, but when you start talking about things like 600-page documents or 55,000 pages PDFs, that 32K comes up really, really quickly. And you realize that the answers that you get back is not the most accurate. It's going to get cut off. So the perfect answer to this is, if only we have some way to get an answer, or to get to be able to just give it a 50-page questionnaire to say, hey, this is what I need you to process, and I want you to give me the answers at the end. So to put it into simple terms, you want an AI with a massive brain so that it can take all of these questions that you're giving it and to give you a perfect answer. We'll talk a little bit about that. Lastly, it's just about how it's being used at the moment. We can do it for language translations, Q&A, text generations, and virtual voice assistants, which I'm sure everyone is quite familiar with. All right. So at this point, I was asking myself, like, okay, I know what ChatGPT is, I know what LLMs are, but how does it actually work? Because LLMs, it's not a new thing. The technology that it used has been around for a while, but it was only until the recent years where transformers came out, and that changed everything. So let's quickly talk a little bit about that. So traditionally, what happens is that with text models, they can only process one word at a time, which means that if I'm looking at this sentence, how it works, it needs to go through word by word in order to process it. It's fine if it's a short sentence, but if you have a massive paragraph, it means that you need to wait. So if you've got 5,000 words, you need to wait for 5,000 words to be processed. Now, the next problem with that is that because of its limitation, it is very forgetful. By the time it reaches the end of the 5,000 words, it forgets the first, say, 1,000 words. So that's not a good thing, because it slows everything down. You have to go through it again. You have to find workarounds. And in that way, it makes it really difficult to train. So what's the solution? Google introduced the transformer in the 2017 paper, and it's called Attention is All You Need. So the transformer managed to fix all the problems we just talked about, and it became the foundation of models such as ChatGPT and Bard. Now, when you think of transformers, you might be thinking of this, one of the robots that you've seen in the movies, but it's actually not the case. Transformers look a little bit more like this, which to me is extremely complicated, and I have no idea what it still means. But that's not our concern. What we just want to know is how it works. Now, at this point, you might be wondering, okay, I've seen the word GPT, 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 but what does it actually mean? So the G in GPT stands for generative, which simply means I'm going to autocomplete whatever you're asking. P stands for pre-trained, which means that it's already been trained up by the guys at OpenAI. They've gone through all of the work to put in all of these informations, to teach it about rules and settings. So it's ready to go, which means that you can take this and use it in any application or software that you want to build. So you don't have to go through that whole process of just retraining and reprepping and teaching the AI what is A, what is B, what is C. Lastly, T is for transformer. Now, there's a lot of different variations and meanings, but to keep it simple, we're just going to call it a word wizard because we're talking about text here. Now, what makes transformers really good and different? You see, in 2017, when it came out, there was not a lot of noise. It was exciting for the engineers and scientists in the machine learning field, but for normal people like us, we don't really know about it. I didn't know about it until I started reading it. So what makes it so good? So the first thing is that they figure out what to focus on. So there's this keyword called attention. Now, attention isn't just a buzzword that they use in the presentation or in the paper. Attention, like us, so for us humans, when we look at a sentence, say there's a sentence called Sam was ready to fly his kite when he noticed a fly on it. So say we're trying to figure out what's the action for the kite. We focus on the word fly, okay? And the next word is his. Who is his? Okay, his refers to Sam. And then the next word say kite. Okay, I know that this is an object. There's all these relationships. Now, why this is important is that for transformers in the past, so in the past, we had to rely on the AI to read word by word. With this focus for attention, it means that no matter how big the paragraph you're feeding, it's able to quickly remember and understand which is the right words to pair with each other. The second thing that makes it really impressive is that it understands and remembers the order of each word. So going back to the same example, Sam was ready to fly his kite. Now, for us, we are familiar with the way English sentence is structured. So we know that if Sam was ready, if someone asks us that word to fill in the blank, we know that it needs to sound that way. Sam was ready, John was busy, etc. There's that standard structure that's in our head already. So what AI does is that it basically puts a number next to each word and it remembers, okay, cool. If I look at this sentence, Sam was ready to fly his kite. I know that if another variation comes up, it needs to be was ready to blah or when blah, 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 blah. So repeat this, say 50 billion times, and you have an AI who memorizes these rules by heart. So this is what we've called positional encoding. Finally, the best thing about this is that they can do a lot of processing at the same time. So instead of waiting one at a time, it's able to process everything in one shot. So to understand this a little bit better, if I had two of me, I'll be able to do things twice as quick. Or if I had 4 arms, 6 heads, same thing. I can do a lot of this much quicker. Now, all of this sounds really, really exciting, but with great power comes great responsibility. We need to know how it actually impacts us. So when we talk about impacts, the obvious thing is that it's going to help make our lives easier. It's going to help us to understand what's the workload, how we can make things much quicker, how we can let machines do the boring stuff that we don't want to do. And that in turn creates productivity. Second point is that it's really forcing a lot of businesses to rethink the way that they do business, they run operations, because now with this amazing tool, what do we actually need? What is our focus? How do we incorporate this? The third point, I think, which is the most important, is to actually increase the access to information in the sense of knowledge, services. Services could be services like myself, IT, legal, and so on and so forth. And finally, justice. Now, we know that there are a lot of different services that are quite exclusive because of the costs involved, because of the expertise and knowledge involved. So with AI, what this would help is that it expands the access to all of these different services, and this would create a better and fairer society for everyone. One thing to also mention here, which doesn't get mentioned a lot, is that the mental health space. So the mental health space, we understand that it's not actually easy to get a therapist. because of the processes involved, the costs involved. So even though it's not recommended, there are a lot of different people that use it as a sounding board. It's a good way for people to get help, and I think it's got its benefit. So then we can talk about ethical concerns and risk. Hallucination is a big piece, which I'll touch on separately later. But one of the things we need to remember when we interact with large language models is that there's a concern about bias and discrimination. So the easy way to describe bias is that because these large language models are trained on different data sources, the question then comes up to say, what is the data source that it's being trained on? Is it trained on scientific journal where there's a lot of proven facts? Or is it trained across social media where there's a lot of varying opinions, discrimination, and so on and so forth? Because it's learning from that. And naturally, the answers that it gives will be biased in some shape or form. The other thing we want to talk about is how do we make it accountable? So anyone can say anything on the internet. It's able to spit out different things left and right, but there are consequences if you say the wrong thing. So who actually takes ownership of that? And what about transparency? Where did it get its data from? Who's actually training it? All these other questions that we need to be thinking about. And finally, we have the classic misinformation and manipulation. There are a lot of misinformation sources out there now. We've seen deepfake videos, so on and so forth. We've seen bots spamming Twitter, Facebook, Instagram, the likes of all that. AI is going to take that to the next level. So this is something we must keep in mind, and we must be smart about it to say, how do we put in measures to make sure that we address that? So a very good example here is that there was a news in Reuters. So there was a man that was generating a fake news using ChatGPT about a train crash. This was one of the first arrests in China in an AI-related probe as the government tries to control this kind of outbreak. So this is probably the first of many to come, and I think we can expect a lot more in the time ahead. Now, on the legal side of things, there are a few things we will talk about. So defamation is one of the pretty straightforward one. There was a pretty high-profile case back in April. So to make it short, there was an Australian man where ChatGPT had named him as a guilty party in a bribery scandal, which actually turned out to be not the case. Now, this obviously caused a lot of distress for him, and it highlighted the need to have some kind of regulations because depending on the source that ChatGPT was trained on, we could be giving out wrong answers, and it's going to tell you that in a very confident manner. IP rights, copyright violations. So this goes back to where it's actually getting its information and training data from. Is it being trained on data that's proprietary? Has it gotten permissions for that? We don't know. And if it does, what do we do about that? Data protection, privacy, and consent. So as a lot of us in the legal industry know, there are a lot of rules and regulations around data, and it spreads across different countries, and every country has its own rules. So that's something that we need to consider. Privacy. Have I been advised that this information is being used for training? Have I given my consent? So say if there was an article on me on the internet, I didn't allow OpenAI to take information from there. Now I'm feeling distressed. What are they going to do about it? What can I do about it? And finally, just about frameworks. So AI is a very large piece, and it obviously impacts us in a lot of different ways. I think it's important that there needs to be guidance from someone to provide some regulations, and so that we can use AI in a safe and efficient manner. Now we'll talk a little bit about hallucinations. So the word hallucination basically means making things up. Now, as you have read in the papers some time ago, LLMs do hallucinate. So the screenshot on the screen is a good example. I got this 3 weeks ago. So I asked Bing AI, I said, tell me a few examples about AIs. And it told me about Bard. It said Google created an AI that could generate music from text. It's called Bard. And I said, no, I don't think that's right. So I asked Bing AI, I said, are you sure that it can generate music? Can you justify your findings? Can you give me evidence? It then went back to search and said, oh, I apologize for the confusion. It seems that Google Bard doesn't actually generate music, which is a bit concerning because Bing AI has been out for some time and it's still making these mistakes. And it's even confident because it's providing sources for me to click on. Now, when I click on the sources, it brought me to an article, and it could show me that, yes, Bing AI is in the paragraph, but it's not related. So the short answer to why it's actually hallucinating is that LLMs don't actually think. What they do is that they're actually looking for the closest pattern in the database. So what this means is that if I ask it a question, it's going to look through billions of examples in the past, and it return me with the most likely combination, possibility, or pattern that's available. It doesn't know if it's right or wrong. It just knows that it's the highest possibility. Now, these patterns obviously are trained data from the internet. So can we trust it? We're not sure. Who's going to say this is incorrect, this is correct? And because it's so confident, you sometimes get fooled. And if it doesn't know what it's talking about, it just tell you, like in the screenshot, just a very confident, incorrect answer. And here comes the question about if LLMs can't think, can they actually understand the concept of justice and ethics? Because all it's doing is that it's auto-completing an answer for you. Can we then trust it with these delicate, serious matters such as legal proceedings and so on and so forth? Because if 50 people are saying the same wrong thing, it's just going to spit out the same wrong thing to you confidently. Now, what's interesting though is the future ahead. So we're going to talk about a few things very, very quickly. Some people may have known about this already, but GPT-4 is able to process images and text at the same time. Now, it's not available in ChatGPT. It is available in GPT-4, where they have built a module for this app called Be My Eyes. So it's an app that helps the people with disabilities who can't see. So in the screenshot, someone's taken a photo of items in the fridge, and GPT was able to just say, cool, based on the items in your fridge, here's a couple of meal ideas that you can do, which is pretty impressive. The second thing we talk about is the improved ability to identify unknown patterns. So what this means is that I could just say, give me examples of X, and it could just spit out all of the relevant examples that I may not even know. Another way to use this is in hospitals. So if we say, so the image on the right is a X-ray. So if we look at it, say from the second point, we could teach it to say, identify unknown diseases such as COVID, and it's able to pick up different points for us. The third point I want to touch on is the tokens. So as we know earlier, currently transformers are limited by the length of the token, but this was just 2 days ago, I believe, if my memory serves me right. Microsoft has just talked about it in a recent paper. Their model can actually take up to 1 billion tokens. 1 billion is a lot. So if we have 1 second to 1 token, 1 billion is about 30 years. So what that means is that we could potentially put the entire internet into the question, and it will be able to answer it pretty accurately. Now, this is not available to us yet. It's sitting in some of their supercomputers on the other side of the world. So we're still some time away. But computer manufacturers and chip manufacturers, they have been pushing out new technology. So we may be looking at a future where home computers may be powerful enough to run these models. Now, this is probably the most interesting part of the conversation here. How do we actually manage something that's smarter than us? If you look at the screenshot there, OpenAI has released an article on 5th of July, and they set it up front to say, look, we currently don't have an answer if we have a super intelligent AI going wild. I think it's a bit concerning because these are the top guys on top of the world now. They've got backing of Microsoft, and they're openly admitting, look, we need help. And OpenAI is actually putting about 20% of its computing resources over the next 4 years to put together a team to address this issue. Now, what they hope to do is to create an AI to control an AI, which we'll see what happens. And the final thing is, why should we care? Because if we use fire as an example, fire is something that we understand very, very well. We understand how it works. We understand its limitation. We can control it, even though we're scared of it. But what if one day fire decides to go out of control? It could catch fire anytime. If it doesn't like your face, it's going to just burn the whole house down. I think that's going to be quite concerning. And finally, I think what's really important to say is that if the creators of a product are openly saying they need help, I think we need to pay attention to that. And this is only just around the biggest corporate product that has been out there. There are open source AI, which is on the internet, and we still need to look at those as well. And last point is just about the European Union. So they are pretty close to passing the world's first AI law, and it's going to cover the creation, use, and real-world application of how we do things. And I think this is going to set the precedent of how the rest of the world will follow. So like I mentioned, this is only just about corporate level AI. What about open source AI? Now, I think it's quite interesting because a lot of us here don't have any background in robotics or tech, but we're listening to it, we're learning about it, and lawmakers are scrambling to discuss what this means. I think this symbolizes the impact this technology has on all of us, regardless of our background. So therefore, there's a need for regulation, but we mustn't stifle creativity at the same time. And I think with that, I am done. Thank you, everyone.
Fantastic presentation. Thank you, Stan. Really, really appreciate it. We are right on time. So what I'm going to do is suggest if folks have questions that they want to put to Stan, please be sure to contact him. I know that he's on LinkedIn and available on a bunch of other social media sites. So do please reach out to him with your questions, and I know that he will be sure to answer them. And of course, likewise, stay in contact with us at the centre. We would love to hear from you as well, and can also pass on any of those questions that you have for Stan as well. So do stay in touch. We look forward to seeing you. Thank you very much, everyone, for coming along today. And Stan, again, thank you very much. An absolute pleasure to have had you today as well.
It's my pleasure. Thank you so much.
Thanks, folks. Until next time. Bye now.